So just a second, I will open that model itself. Just a second. So if you remember in that model, we had that central pillar kind of thing, and on top of which we wanted to stack the heat sink fins. And for that, we had created that difference operation, so that just on top of that central cylinder, we can include those fins. We did not want to have any central surface to get created inside that central cylinder, and that's why that difference operation was used. So I will just open the model itself to show you what exactly I mean by that. Just a second. So yeah, then there is another option. Is the fillet option not readily available in 3D, or is it dependent on the COMSOL version? So 3D fillet option is indeed available in COMSOL if you have access to design module, the 3D fillet. If you do not have access to 3D this design module, then you will not be getting 3D fillet option. Just the 2D fillet option will be available. Yeah. Yeah, there is one question, is that after using the difference operation, I am getting this error. You need to provide input objects property input. Can you please tell me if I missed out on anything? Yes, please check your difference operation. In that difference operation, you need to provide two types of entities. That is objects to add. That is nothing but from which bigger object you want to subtract the smaller object. So first of all, enable the selection on that objects to add proportion, and after that, once that is done, once the object is selected, include other selection, other object which need to be subtracted. So I will just show you my screen. Yeah, so this is the example model that we yesterday we had discussed. And in that this example model, you can see that this is the geometry that we have taken, and under the work plane we have done this difference. So here you can see that in difference, first of all, we have selected this cylinder, this circle 2, that is the outer circle, and from that outer circle we wanted to subtract this inner circle. And if you are not adding any of these objects, if you miss to add any of these objects, you will end up having the error that you are getting as of now. There is a question, how to draw three-phase conductor in cylinder. I'm not very sure what exactly your question is, because see, for the three-phase conductor, you might be having different designs also. And for example, it could be like just the three cylinders you may want to draw, and while applying the physics, you can apply the current or the voltage which is having some phase difference in that. So there isn't anything specific geometry command where I draw any three-phase conductor. Okay, so one of you are mentioning that the fuse model which was taken, it was mentioned that it is having some 13 amperes current, but you are not getting it, right? So as of now, I do not have that model with me. What we can do is, in tomorrow's handout, we can include the models which were discussed in also, so that you can go through those model files. Yeah. Yeah, could you please explain the solution to assignment 2? I mentioned that the solution will be shared with you. Solution 5 will be shared with you in, uh, when we are sharing the recording for the today's session. But this is how the solution will look like. What is expected from yesterday's solution, because still few people are submitting. So here you can see that supposed to draw cylinders. First of all, the very first cylinder is the outermost disc what we are having. Then after that we are adding another cylinder in order to get the through and through holes. Then we have used the rotate feature in order to get the same cylinders drawn in the circular array. As I had mentioned in yesterday's session also, right? By using rotate feature, you can get the circular array. The same way this rotate feature has been used. Then we have used this difference operation from the bigger cylinder. We have removed the smaller cylinder, subtracted, and this is how the geometry looks like at this stage. The next is once that difference is done, you can see that we are filleting the edges. And as I was mentioning, the 3D fillet option will be available when you are having design module. So one of you are asking that you are having some other version, and if the fillet option is not included in that. First of all, please see that if you are having a design model license or not. And that's why I would suggest that for any hands-on sessions or any assignments, please do use version 5.5 with the trial license that has been provided to you. So with this, you can see that this is the fillet that we have created. Then we have drawn the spheres. The first sphere, again, we have created circular array with rotate feature, and again from this filleted object, that is this circular disc, we have subtracted this spherical that array objects, and this is how you will end up having the final geometry. Next question. Can we have bidirectional coupling only with CAD tools, or codes can also be coupled? So the bidirectional coupling we are having with lively products. So for example, I can just show you the product suite itself. Just wait for a second. Yeah. So in this page, you can see that this is the product suite. And in that product suite, we are having these liveling products, that is the interfacing products. And in those interfacing product, definitely we are having some bidirectional coupling between different CAD products, but we also have bidirectional coupling between COMSOL and MATLAB, and COMSOL and Microsoft Excel as well. So these two livelings are possible. And when you are having typically that liveling for MATLAB, right, you can couple or you can get MATLAB functions directly called into COMSOL model, or you can write your COMSOL model in MATLAB environment as well with in the .m format. Again, but over there also you need to establish that liveling between MATLAB and COMSOL in order to access COMSOL solvers within MATLAB environment. How to use copy move that was used in yesterday's model. So here in this case, we had used this copy feature in order to create copies of the first IC that we have created. In similar way, if you want, you can also use this move feature as well. If you want to have, you can just select whichever the object that you want to have. In similar way, you can provide the displacement vector as well, and you can move the object in that way also. That is also possible. How to keep a part of the model hidden in 3D? If you want to hide certain part, right? For example, I am just building this entire geometry, and hopefully you can see my screen. Yeah. So here in this case, if you want to hide some parts, so in that case, you just need to go to this click and hide option. You can see, right, this the click and hide option itself, which is given over here. The little eye symbol, which is having some cross given on that. So first of all, you will need to activate that. Once you activate that, you need to go to this select object button. So here COMSOL will ask you that which entity level that you want to provide that hide option. That is whether it is at object level, domains, boundaries, edges, etc. So in that case, I can just say that it is select boundaries, for example, or the select domains. If I click on select domains, you will see that my cursor has changed into this same format. So if I click on any geometry object which is at the domain level, it will be hidden. So this is, I'm hiding this, I'm hiding this. Now here you can see that this disk stack that we are having, these are like the 2D disks, the boundaries only, and hence they will not get selected when I'm selecting the domains. Now if I just try and go, I can just reset hiding. I can click on this button and do the reset hiding. Once that is done, if I want, I can also select some boundary, and over there you can see that any boundary then in that case can be selected. This is how the hide and unhide option works. In order to come out of this hide option, you just need to click on that button again. That is kind of a toggle button that we are having. Yeah, what is the difference between absolute and relative tolerance? As I was mentioning yesterday, the absolute tolerance is equal to the relative tolerance times the maximum coordinate of your object. So, for example, if you have drawn some, let's say, some cube or so, and if that cube dimension is 1 meter by 1 meter by 1 meter, or the 10 meter by 10 meter by 10 meter, and let's say that a cube has been drawn by keeping its corner, one of the corners at 0, 0, 0. So in that case, the maximum coordinate for this cube is going to be 10, 10, 10 only. Okay. Now, if we say that if the relative repair tolerance is 1 e power minus 3, let's say if the relative repair tolerance is 1 e power minus 3, in that case, the absolute tolerance is going to be 1 e power minus 3 into 10, that is 1 e power minus 2. And whatever the gaps, whatever the entities which are smaller than this particular tolerance will be merged. And that's what this tolerance is calculated. And hence, means even though it is just a cube over here, you might be having some complex geometries. So always ensure that the absolute tolerance will be calculated based upon the maximum coordinate of your geometry into the relative repair tolerance, if you're mentioning the tolerance in terms of relative repair tolerance. Whereas if you are providing the let's say the geometry that you have drawn, that is same, the 10 by 10 by 10 geometry only, rather than starting from 0, 0, 0, if you are starting it like at let's say 10k, 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 that is the starting corner point of that cube that you are having, then in that case, the relative tolerance is going to be 1 e power minus 3 into 1 e power 4. That means you will be having relative absolute tolerance as 10. So that means if you are having such kind of absolute relative tolerance for the geometry which is located at really very far from the origin, in that case, your absolute tolerance will be will work in such a way that your entire geometry also may get removed from your geometry sequence. Hope that answers your question. How to fix the origin? You cannot fix the origin. You can get your geometry. You can move your geometry, or while drawing the geometry itself, you can ensure that the geometry is drawn closer to the origin itself. Means, for example, if you are drawing a block, you can say that whether the corner or the center, if it is closer to the origin itself or not. If you are drawing a cylinder also, then directly the cylinder center position is also can be provided. So for each geometric primitives, the position is always asked by COMSOL. And then in order to, means while providing that position, you need to ensure that that position is closer to the origin. In the assignment problem, even if the geometry creator has same as the given assignment, the volume computed was checked as wrong. Would you please explain the assignment? I just discussed the assignment, the steps also. At the same time, as I was mentioning, we will also be sharing the assignment solution by today evening, and you can definitely go through that. How the what are the steps? Just check that if you have missed any means one of the dimensions, whatever the value that you are providing, that might have been given a little differently, or the units, whatever we have asked you, whether the units are given differently. Because of that also you might be getting a different volume. Yeah, the next question is how to create a hemisphere on top of the cylindrical surface. If I make a sphere such that half of it's into cylinder, will it give the same result? Yes, it will give you the same results, because ultimately you are going to just do the difference operation itself. That also can be done. So here in this case, you can see that we have drawn this complete sphere. If you want, you can just draw a hemisphere and then use difference operation, that is from the entire object. Those you will be having an array of the hemispheres, and that can be removed, because the resultant object is going to be the same only. Can we perform copy operation with some rotation? So with copy operation, if you refer over here, with copy operation, you can see that you can provide the displacement vector, which is nothing but means the straightforward is in the linear vectors that you can provide for here, which is the easiest way of doing it. If you want to create a rotate, right, then rather than using copy operation, you can use the rotate feature itself, and it will create a copy of your objects in order to get the circular array. Yeah, what is the need of convert to COMSOL? Right click on geometry, convergence, and convert to COMSOL. Good question. So here in this case, you will be getting this convert operation as you are mentioning, this conversion, convert to, not conversion, sorry, what, but no, here in this case, I will not be getting that convert to COMSOL operation, because when you are importing the geometry, right, once the geometry import has been done, and if you want to reuse that geometry, reuse in the sense that, for example, you are having two licenses, let's say, and you have imported the geometry, and you have performed some operations, and after that, if you want to use that, send that geometry to someone else who is using COMSOL but doesn't have access to that particular CAD import module. In that case, you can convert that geometry into COMSOL, and then you can start using it. But the disadvantage of doing so could be, for example, with convert to COMSOL, whenever you are going to open that geometry, it will get opened with COMSOL kernel only, and with that, you might be missing some features which are available with the Parasolid kernel or the CAD import kernel. But this is like the imported geometry can be converted into COMSOL MPHB file as well. That's why this convert to COMSOL option is given. How to model the internal structure of a capacitor in 3D? For that, there isn't any what I can say, one set of instruction that this is how the capacitor can be created. It will all depend upon how the structure looks like, and then what kind of geometric features will be required. Means, for example, it is a parallel plate capacitor with a circular cross section, then maybe you can just create a one cylinder itself. And then I yesterday I did not discuss much about that, but with the cylinder itself, let's say I'm just having a cylinder, and with that cylinder, let's say first of all I'm going to go create cylinder with let's say some radius equal to 1 and height equal to 5. Okay, this is the cylinder that you have drawn. Now another option of just partitioning this cylinder will be to use these layers. So let's say I'm having a layer 1, and thickness that I'm going to provide is, let's say, some 1. And here I can say that whether I want to have layers on the sides or top and bottom. I'm just creating layers on top and bottom. You will see that this is how the structure is getting divided. So this is also one of the ways that how you can partition your geometry. So again, means, as one of you is asking that how to model the internal structure of the capacitor, it will all depend upon that what kind of geometry or the design that you are having in hand. Can we pattern whole features in COMSOL? Yes, you can. And that was means yesterday's exercise or the assignment which was given to you has discussed the same thing. Okay. So next question is that in this assignment, I tried to create each cylinder and sphere separately. To figure out the coordinates of each, I had to do calculations on paper. Is there an option like copy or array that can place the cylinder in 360 degrees with different coordinates and angles? Yes, that was the solution that I discussed with you. That first you have drawn one cylinder, two cylinder, that is the one basic cylinder, and on top of that, if you have drawn the next cylinder, we have directly used this rotate feature only. That is in 30 degrees, 30 degrees difference up to 360 degrees, the circular array has been created. That is how you can create your entire circular array. So writing down or calculating coordinates for each and every object is going to be really very tedious, and that's why this kind of rotate feature can be used efficiently. In the given assignment, how can I perform copy operation as I want them in circular manner? So as I mentioned earlier as well, rather than using copy feature, you will need to use this, the copy, this rotate feature in order to get the circular array effectively. Can we draw circle in 3D? Yes, means I guess you are saying the circular surface itself. You can indeed draw a circular surface in 3D, and as we discussed, in order to draw any 2D object, that is like a circle in a 3D environment, you will need to use work plane feature. So for example, if I am just doing some 3D modeling, and in that 3D model, let's say first of all I am drawing a sphere, and inside that sphere, let's say I want to have one circular surface itself, and I can directly go over here and draw a circle. Let's say radius is 0.1 now, or maybe 0.5. I am just going to keep it, and once I select this, maybe definitely you will not be able to see the internal parts. Either you can click on wireframe rendering, or you can click and hide. I will just hide few boundaries. I'm not removing them, I'm just hiding those boundaries. And this is how you can create what I can say, the 2D geometric entity within 3D environment. Yeah, I got the error message that I was using too many steps. I should reduce the steps and try again. I think it was because I made different cylinders for each of the holes. Yes, correct. So as you had used use one step for to create each of the cylinders, the number of steps to create the geometry was really very huge. And in order to reduce that, you can use the rotate feature as mentioned. I guess I closed that model file itself. That as I was showing the assignment, right? Assignment solution. You can use the rotate feature in order to get the entire geometry done in very few steps. So here you can see that we are having this rotate feature. So the number of steps you can just count in your model might be really very huge. Whereas if you are having using these different transform operations, the number of steps required to create the geometry are going to be quite small. That number is going to be quite small. Yeah. Can you please show how to draw 3-cylinder at 120 degrees? So just now I had shown you that how you can have these cylinders drawn at different angles. Here in this case at 30 angles at different means at the intervals of 30 degrees, the cylinders are drawn. If you want, you can change that step size as well. Let's say if I'm just mentioning it as 120, 120, 120, replace. And you can see that this is how the cylinders can be drawn. Okay. How can I delete cumulative selections after adding it could not be deleted? I'm not sure whether I understood your question or not. I will just open it. So let me try and understand that if you want to delete them. So you are trying to say that if you have created these cumulative selections, you are not able to delete them. They can be deleted. The selections you will not be able to delete if those selections are being used anywhere in the materials, in physics or mesh. Once you start using those selections, you will not be able to delete those selections unless and until you remove those selections from here. So for example, this yeah, so means for any type of selections you need to ensure that they are not getting used. Again, this assignment, smaller circle was not completely removed. How can we do that? It was not supposed to be removed completely, and these are not the circles, these are the spheres, as you can see. You need to ensure that where you are drawing means the depth of that circle, that depth of that sphere which is getting inserted inside that circular disc itself. So here in this case, as you can see, the depth of that sphere inside the circular disc is equal to the radius, and accordingly you can first of all draw the sphere and then remove it. Just a second. In Boolean union operations, we should specify tolerance. And is there any tolerance for other operations like intersection difference? And is it compulsory to specify the tolerance? So yes, you need to specify the tolerance that is required for all union operations, for example. Everybody is going to take automatic, and automatic will be decided based upon the dimensions that you are having as well as the geometry that you are on. But if there are any really very small features, or if you are building any high aspect ratio geometry, right, in those cases there might be a chance that the smaller entities may get removed, or intentionally in some cases you want to remove the entities, and in those cases you will have to provide that tolerance manually. Yeah, 6-layer piezoelectric micromirror geometry can be built by starting in 2D builder. Uh, we cannot say that whether it can be started in 2D or not. Again, it depends upon how the design looks like. So, for example, if it is like just some 2D cross sections which are getting extruded or revolved, then yes, you can start in 2D and then you can those extrude or the revolve some parts. Or in some cases, it is like completely the irregular shape. Then in that case, you will need to start with 3D object itself. So it all depends upon what the design looks like, and means by using which primitives you can end up having least number of steps to create the geometry. Yeah, someone is saying that you use difference 2 times, but it can be made by using once. Yeah, that also could have been done. That could have been the least number of steps, I can say. The fillet operation, someone is asking that kindly explain the fillet, please. So the fillet options are available whenever you are having this design module. And with that, for example, if I've just done this difference operation, and after that, I can add this fillet. And for that, I can just select the edges which needs to be used under fillet. And I can provide the radius itself and accordingly create a fillet. Okay. Can you provide clarity on domain and boundary? When you are working for not in 3D, basically for whatever the space dimension that you are working on, the highest dimension will be considered as or the maximum dimension will be considered as domain, and the subsequent one will be considered as boundary. So in 3D, the 3D space dimension or the 3D work, when you are doing working in 3D environment, the 3D dimension is going to be the maximum dimension, and at 3D the volumetric entities will be considered as domain and the surface entities will be considered as boundaries. Whereas when you are working in 2D, the highest dimension is going to be 2D, and in that case the surface objects will be considered as domain, and edges of those surfaces will be considered as boundary. If you are going into 1D, the maximum dimension is going to be that's just the edges, and in that case the edge will be considered as any edge will be considered as domain, and the endpoints of those edges will be considered as boundaries. Yeah. So just a second. Yeah, the next question is that the sequence of the geometry creation influence final analysis we discussed yesterday. So based upon again what kind of design that you are having, in some cases it will not influence. If it is like just you are adding object after one another and directly creating a unified object. Whereas if you are, for example, if you are working on some rotational devices, in that case you may need to create one union for rotors, one union for stators, and in that case it will all depend upon means where at what step that you are creating a union. I will just explain you with an example itself. Just a second. So here you can see, okay, this geometry is just the imported geometry only, but I will still show you how exactly it works. So this is one of the generator example model which is available in our database. And here in this case, the central part, as you can see, this part, these are the magnets, and this part, they are part of the rotor, and rest of the geometry is stator. Now in such cases, the way geometry has been created, first of all we need to have some we need to use assembly over here, because we need to have some relative motion across this boundary. As you can see my cursor, that is the outside part is the stator and the internal part is rotor, and hence we need to create assembly between the stator part as well as the rotor parts. Now here in this case, the way geometry has been created is, first of all we'll be creating the stator part. We will be removing this using the difference operations, and we will be creating one hole over here. Once the hole is created, you need to create an union for the outer object, then create the inner object, create union between the rotor objects, and then apply assembly. And hence in such cases, the sequence will definitely matter, that when you are creating the rotor parts, at which stage that you are creating the stator parts, and how you are uh, creating how these objects are interacting with each other. How to assign? Okay, my colleague Nitish has already answered that how to assign identity pairs in form assembly node. So while creating the form assembly itself, you will see that the pair type you can click as the identity pairs, and once that is done, based upon the how the geometry is created, the identity pair will get created. It may not be just for the structural contact, it might be useful for any physics, that the identity pairs might be used, means based upon if you are using assembly in heat transfer, electromagnetic, anywhere, once you create this assembly, and there you just select option as create identity pair, you can create the identity pair and using any of the physics under the continuity or boundary condition, like this. You can just click on this. If there had been any other identity pair, it would ask me that if you want to add another pair or not. In this case, just one identity pair, and that has been added. That's why it is not showing me an option. Considering the 2D stack of rectangles, I want selection list with odd and even position rectangles. How can I achieve that in design? Mm, Selection list with odd and even position rectangles. If you want to create the selections, you can create the selections based upon what I can say, the boxes that you can create, the box selections or the disk selection that you can have, the wherein whatever the entities which are included in that particular fictitious box or the fictitious ball will get selected. Or else, if you want to select the entities for the odd and even position rectangles, just create user defined selection itself. Just this is like, let's say that odd numbered ones, the same way you can create the selections for the even numbered blocks, and accordingly just apply the material properties. Yeah, the next question is that how do you import that geometry, and that can be done if you right click on geometry, and over here you will see an import option, and that import option you will get that any importable file can be imported, and then based upon the license that you are having, you will be able to access various types of CAD files. I will just show you that what type of files are possible to import. Just a second. So here I am just going to show. Just a second. Hold on for a second. Yeah, there is next question that what is the need of programming options in geometry, right? Geometry programming if you want to implement some programming, just for an example, if you are having certain parameters defined in your geometry, and if you want to say that if certain parameter value is set equal to 2, in that case execute a part of that code. If it is given as equal to, if that parameter value is given as 1, then execute other part of the code. In those cases, this programming can be useful. Just for example, you have created a geometry, and in that you are having this if else loops given, and let's say in that if else loops based upon some parameter values. Now let's say you are running a parametric sweep, okay, and that parametric sweep might be for some voltage values, just for an example, not voltage values, just say that if you are having it for some length value, length or so, for the geometry length. In that case, you can say that if that parameter value is set to let's say L equal to 1, then when that parameter value becomes L equal to 1, execute a one part of the code. If the parameter value becomes equal to 3, automatically COMSOL will decide that which part of the geometry code should get executed, and accordingly the boundary conditions and the physics will be set up. Okay, just a second. I'll just show you the how you can means which file formats are supported in COMSOL. So for example, if you are on our COMSOL web page, there is something called as specification chart. Under that specification chart, you can see that there is a CAD specification chart also given. And here you can see that different CAD formats are given, which are the CAD formats available with different modules. So with base package, you get 2D DXF, STL, and VML. But if you are having CAD import module or other live for other different CAD licenses, in that case, you will be able to import other various files as well, like PRT file or DWG file, etc., or the 3D DXF files if you want to have. All these are the IGS files, which is again a popularly used file. All these files also can be imported. So this comprehensive information given on this our CAD file formats page itself. I'll just share it with you all. Just a second. How to create a shorted circular coil of 10 turns and give AC current of 1 ampere 10 kilohertz. See, this is actually means we do not do it through physics completely. COMSOL has various features means under each physics. Just for an example, when you're talking about the circular coil of 10 turns, you might you can directly create the circular coil maybe using torus feature, or you can just create one circular surface and then get using revolve operation you can create that circular ring. And once that is done, rather than creating the 10 turns in the geometry, there are features called as coil features available in the ACDC module, through which you can directly provide the number of turns in the physics itself, and you do not have to worry about how to draw that geometry explicitly. What is the easiest way to create a hollow cylinder vessel? Okay, interesting question. So just a second, I'll just show you. Whenever you are creating any using any 3D primitives, right? Either you can create them as Just a second. As solid, or you can create as surfaces also. So if you want to just create a shell of that cylinder, in that case you can use this surface object. Yeah, can you please explain elaboratively about definitions in toolbar that is next to home button, use of moving mesh, probes, interpolation function, etc. So see here in this case, there are various options available either in this button itself, or you can get those options when you are right clicking on these components or under definitions also. If it is like definitions, then under that definitions you will see these functions. The functions can be used in order to provide any excitation to your structure, or if you want to have, if you are having some um, mm, uh, functional dependence in your material properties. Just for an example, the conductivity, thermal conductivity is a function of, let's say, some temperature data itself, just for example, or the electrical conductivity is a function of the temperature data which you have opted from your experiment, and that lookup table if you want to import in COMSOL. So in that case, the interpolation function can also be used. Then selection that we have seen, probes are nothing but if while the analysis is running, if you want to evaluate certain quantity at a certain boundary, at a certain node, while the simulation is still running, means if you want to see the runtime progress of certain variable at certain point at or certain boundary, in those cases this evaluation, the scalar evaluations can be done using this probe feature. The moving mesh technique is typically used if you want to, what I can say, it comes under the deform meshes. So for example, if you want to have relative motion between any two objects, it could be the linear motion, it could be the circular or the rotational motion. In those cases, either the moving mesh is already incorporated in our inbuilt physics interfaces, like if it could be FSI interface, wherein fluid structure coupling is done by incorporating the moving mesh interface, or it could be the rotating machinery interface as I was showing you, wherein the rotation has been captured by means of moving mesh interface as well. The next, just a second. What is the significance of these two tolerances? We just discussed some time back that what is the difference between the relative repair tolerance and what is the what do you mean by the absolute repair tolerance? Absolute repair tolerance, when you provide directly, that tolerance will be used to see that which object should be merged. Whereas if you are using providing relative repair tolerance based upon the geometry, the absolute tolerance will be calculated and accordingly the geometry will be treated. So there is also one question that please share the answer for the poll question 1. So I will first of all show that poll for question 1, what was discussed yesterday. I hope you can see my screen. Yeah. So I will just show that poll question. Mm, maybe that poll question 1 has not been added over here. But if you remember that the poll question answer was given as option C, if you remember. Just a second, let me fetch the poll question itself. Just a second. Yeah. So this was the poll question that was given, that how you can use these scale values while changing the units. This was the poll question that we have discussed. And in order to change the length from 1 micron to 1000 meters, you will need to use the option C, that is select values while changing the units first, then change units to nanometer and rebuild it. Once it is done, then go back to that scale values while changing the unit section, deselect that option, change the units to meter and rebuild it. Please try this out and you will get to see that you are getting the 1000 meter rod from when you are starting with 1 micrometer. Yeah. In today's stack question, I need to have dynamic. So in that case, if you want to have a dynamic control, that is, if you want to change dynamic, in the sense I am saying that based upon the value, in that case you can specify the number of fins itself as a parameter, and while creating that linear array, when we are just having those circular objects stacked one above another, in that case you can directly provide the number of fins as well as the spacing between the fins based upon the parameter itself. Okay. The first assignment, we have already sent the solutions, so please refer to those solutions. And if you still have any questions, please feel free to write to us. The scale values while changing the units, it was discussed in yesterday's session. At the same time, just now also I mentioned that if you are creating the geometry, this is a geometry that you are creating, and with that geometry, let's say I'm starting with micrometers, and then with that micrometers I'm creating a cylinder first. Okay. Okay, so here in this case, once the cylinder is created, let's say while creating the cylinder I am just creating it with 1 micron height and let's say 0.1 radius. This is the rod that we were discussing about. Then to change change it to 1000 meters, what we can do is, first of all, go to geometry, select scale values while changing the units, then change units to nanometers. I can come here and I can click on build selected. So here you can see that it is showing 1000 nanometers is nothing but the 1 micron only. But our objective is we get 1000 meter only. Now I can go back to geometry node. I can just change the scale values and just I want to simply change the units without changing the value while changing the units. And then I'm just changing the meters. And if I go back to this cylinder, you will see that now I have arrived at 1000 meters only, without changing my explicitly the number over here. Rather, I just played with the scale values while changing the units. Again, in this case, it's just a one object. That's why you may think that directly changing this value might be easier manually. But if you are having lots of steps under your geometry sequence, then using this change values, sorry, scale values while changing the units would definitely be helpful. So how to model internal structure of capacitor, that we discussed already. How to provide tolerances in COMSOL, that also we discussed. Can I draw geometry in motion? Interesting. See, the geometry that you are going to draw is a fixed geometry. You can provide motion to that geometry, let's say directly by using this moving mesh technique as well. Or if you want to see the parametric analysis, like that at one certain position, what is the result? Then next position, what are the results? Then in those cases also, you can use the parametric sweep operation. How can I use the geometry created today in another simulation? How to convert the file into MPEG bin format for importing to other COMSOL simulation? So once the geometry is created, you can directly click on this export button. And with that export button, you will see that you can browse wherever you want to save and then export it. However, if the geometry is created in COMSOL and if you want to use the same geometry in another COMSOL file, one thing is you can export it, or else, let's say if I'm just saving it, and let's say the geometry I'm creating, it is like L, and that L is defined as, let's say, 1000 meters, just for an example, and I'm just saving it. Okay, now let's see if I'm just starting new COMSOL instance. Rather than exporting, you can directly use the same geometry sequence in new COMSOL model file. The geometry, then insert sequence. Insert sequence will point to the COMSOL model file. I can just click on that open. And you can see that when I'm just inserting a sequence, the parameters required to build the geometry will also automatically get imported in the new COMSOL model file. So rather than exporting, you can also try with insert sequence operation. Okay, the fillet feature we have already discussed. The 3D fillet operation also I have shown you how you can do that. Could you please illustrate work plane creation and use over an already created 3D model? So the work plane and use over already created 3D model. One thing that you can do is I can right click on geometry and then work plane. Here in this case, either quick or the most popularly used is the face parallel. Means while creating the geometry, it is always recommended that you should always be taking the reference of the previously created geometry so that the alignment will be proper in your entire geometry sequence. And that reference can be obtained if you are using whenever it is possible. It may not be possible always, but whenever it is possible, you can always use this face parallel face parallel work planes in order to create the next geometry. The advantage, as I was saying yesterday also, that you can use that directly just the quick plane which is parallel to xy. But in that case, if I just use this quick plane, right, you will see that you may see that here in this case the cylinder itself is located at 0, 0, 0. But if the cylinder is located at some other position, let's say I am having x equal to 1, y equal to 1, z equal to 1. In that case, if I am just using the quick work plane and if I go to work plane, you will see that the center may not, you may not get at the required position itself. Whereas if you are having the face parallel, you can ensure that the center of the object is located at the local 0, 0, as we have seen yesterday's example model also. So here in this case, I can just create another circle, let's say 0.1 radius. That is very small maybe. And once that is done, I can just extrude it also into one let's say, in the reverse direction, and one I can just say 50, which is still a very small compared to the 1000 meter height that we are having in this direction, as you can see. So this is how you can create it. how to create shadow structures that we have already discussed. The rotate feature also we have discussed just now. Now you can use the rotate feature in the assignment section also we have discussed that this is the rotate feature. By using the rotate feature, we have given the axis of rotation, that is the Z axis. Around that axis we want to provide the point on the axis of the rotation, that is where that axis is located. Here is our that is the center of the itself, and then you can provide the angle in which you want to have that rotation to happen. Okay. If we need to select all the elements of an array, do we need to select individually or can that be done at once? Well, you can select all the objects which are present in one image. Just by, for example, if I am just this, let's say I'm just adding some physics over here. Let's say some dual seating physics that I'm adding. That physics doesn't matter. I just want to show you you can select everything together. Now here in this case, let's say I'm just applying some here in this case it is just one domain that I'm having, but if I'm applying some electric potential boundary conditions, rather than selecting those boundaries one by one, I can either select a box, that is select box, create that box. So the entities included in that box will get selected. If you want to select everything over here, just keep cursor over here, and from your keyboard you can press Ctrl A. Everything present in that pane will get selected based upon which features you are at. If you are at the boundary level feature, all the boundaries will get selected. If you are having many domains, then all the domains get selected in the domain level feature. If you are at the point level feature, like some ground that I'm having, and just doing that Control A will select all the points also. How to draw lens geometry? Well, with ray optics module, we are having some part library already present, wherein you get different lens parts which are already created in COMSOL, which are the parameterized one. So you can check that also. While using difference operation for cylinder and sphere out of 12, okay, that you are having, here I will just change it to 30, 30, 30. Someone is saying that while using the difference operation for cylinder and the sphere, one remains without getting the difference. Maybe just check that here in this object to subtract, if you are selecting all the required spheres or not. You might be having some additional spheres which are created. That could be the reason. How to define space between two geometry as domain? Well, as COMSOL is a finite element software, so everything will get solved, or everything will get discretized into smaller mesh elements, and then it will get solved. So even though if you are having some air domain between two solid conductors, in that case also you will need to draw that solid domain, or you need to draw that air domain between two conductors through geometry. Once you draw that, then you can select in the physics interface. So the space between the two geometry as a domain, for example, just to demonstrate, if I want to have a 2D component, let's say, and in that component, if I am just let's say some sketch, I'm just drawing one rectangle over here. Then the next rectangle I'm going to draw over here, let's say. And if I'm just creating the form finalization itself, then in that case you can see I will not be having anything which is connected with connecting domain between these two boundaries. In order to have, and after that, if I just add some physics, let's say some um, electrostatics physics that I'm adding, as all of us are aware of that. So here you can see that domain 1 and domain 2 that we are getting selected. Nothing in between these two domains will get selected. And while solving the problem, it will get solved on the mesh only. So there isn't any mesh present in these two connecting these two domains to connect. There will not be anything to get solved. If you want the space to be considered between these two, otherwise these two objects will be considered as two disjoint objects, to separate objects. They are not communicating with each other. If in order to have a communication established between these two, what one can do is, let's say I can just go to sketch node again, and I can just enclose these both the things in one box. And if I go to electrostatics now, and maybe if I just go to mesh, you'll see that the entire domain is getting meshed. So there is a connection, there is a space. It could be the entire domain, or you can just draw the small path over here. This is based upon what physics that you are solving for. Okay. Okay. So this is also done. Just a second. Let me check the next questions. How to make a nano composite layer, like nanofillers incorporated in a polymeric layer? Well, see, in geometry, again, you might be having, you can create such kind of geometries wherein you can have one layer, because while creating the geometry, it is not going to say that which material that you are going to go use. It will just treat as a simple geometric object only. So in that case, based upon your design, you can have one solid slab, and inside that you can have some nano pillars, nano filters, whatever the design requirement is. However, based upon the physics itself, you can see that whether you need to draw all those things in your geometry or not. We do have some composite material module also, through which means it offers various types of theories, and in that case you will not need to draw those layers explicitly. Instead of that, directly you can just provide the layer information, composite layer information in COMSOL physics interface itself, and accordingly the composite will be considered. If you are interested, I will just ask my colleague Nitish to send you some example models on composite modeling. Yeah, there is one more again question, that if else, that we have already taken, how to use that programming if else in COMSOL. Yeah, how to select materials between the conductor and core in cable. So yes, that's what I was saying. In order to select a material between any two objects, it could be like, if you are just considering the 2D axis symmetric, let's say this is the core, and maybe you are having a conductor, and in between space that you want to have, you need to have a solid domain between those two geometric entities. Unless until you are having a solid domain created, it will not get meshed, and it will not be considered for any physics assignment. Yeah, I understood 2D and 3D geometry problems, but what is the necessity of 1D and 0T? So, for example, again, means 1D, as I was mentioning, if there isn't anything changing, any variables are changing in other two dimensions, then the 1D modeling will be required. Just for an example, let's say I can say some pipe flow physics or so, wherein you know that the flow across the cross section is not changing, but it is just changing along the length itself. In that case, the 1D simulations will be required. The 0D are space independent. It is like, if you are from electrical background, you would see that the circuit simulations, wherein you are just going to use the lumped electrical circuits only, or if it is like lumped mechanical circuits, if you are having just as spring damper systems, or if you are having, means in COMSOL we also offer thermal lumped circuits as well, wherein all the equivalent thermal resistance sources, etc., can also be incorporated in terms of its equivalent lumped elements. So whenever you are using any lumped circuits, then the 0D modeling will be required. And in many cases, you also want to couple these 0D models to 3D models also. Again, I will go to like very basic examples of if it is a capacitor, let's say, and you are providing some capacitor that excitation through some, let's say, some voltage, that voltage source which is connected to some lumped resistor, and this circuit is connected to your 3D capacitor which you have designed in COMSOL. So in that case, you can create your circuit interface wherein the lumped elements can be added. You can create your 3D capacitor model which is going to be studied, and then you can couple this lumped electrical circuit to your capacitor. The same way you can provide some excitation to any of your electrical machines, or you can take output across any lumped circuit for your electrical machines, just to give you an example. Yeah, if you are not able to find fillet options in geometry, please check that you are using version 5.5 with the trial which has been provided to you, because with trial you will be getting access to all the modules which are which are shown yesterday, and with that you will be able to see the option of 3D fillet. If you are not using version 5.5 that we have provided, you might be using your own license, and in that license you may not be having the design module license, and that's why you may not be able to find the fillet option in your COMSOL installation. Okay. Just checking the next questions, because uh, lots of questions are answered by my colleague Nitish as well. What is the difference between the cumulative selection and the identity pair? Well, the usage itself is quite different. The identity pair will get created when you are using form assembly. And as I was mentioning, when you are using form assembly, the same set of boundaries will be having different identification from two different domains. So, for example, as we were discussing earlier, that maybe I will just open that generator model again. That is quite, with that, it will be quite easy to explain. So let's say this is the generator model that we are having, okay? So geometry has been imported, but that was earlier created in COMSOL. So here in this case, we are using form assembly, and we are creating the identity pair. And here you can see that this is the pair that we have created. Now, because we have used assembly, the same boundary has got different numbers from the stator point of view and from the rotor point of view. And how you can visualize that? If I go to this view node and click on show geometry labels, you will see all the geometry labels. So for example, if I am at this identity level, and if I just zoom in, you can see that same boundary from the rotor side is having number 122 assigned, and the same boundary from the stator side is having number 33 assigned. So whenever you are using this form assembly, the identity for each boundary means it will not be treated as an internal boundary, but it will be having a collection. You will be having a collection of two overlapping domains, and in that case, in order to ensure the field continuity across that particular boundary, first of all, this identity pair needs to be created, and after that, that same pair needs to be selected under the continuity boundary condition as well. Now, when we are talking about the cumulative selection, these are selections, they are not created in order to, what I can say, they are not having any, they are not defining any physics to that cumulative selections. These are like just the one group of boundaries or a group of domains or the group of edges that we have created, just the ease of use. so that whenever we need to call a certain set of boundaries, certain set of domains, instead of calling them one by one, by using various selection techniques, we can directly create those groups a priori and call those groups. Okay, next, to select space between. I do not get rotate when I right click the geometry. So if you right click on geometry, if you go to transform, you should be able to see this rotate feature. So directly, if you directly go to geometry and try checking for rotate feature, you may not be able to find it. Under transform, the rotate feature is available. How to add rotation in the object? If it is like how to rotate the object in order to get the rotate that circular array, then the rotate option is provided. If you want to rotate, provide the physical rotation to the object itself, then well, you can use this moving mesh technique. And as we are discussing over here, and in that moving mesh technique means when you are adding that moving mesh interface, you can have various types of options. Like very first option is the rotating domain, and when you are adding the rotating domain, you can directly provide the rotation of that particular domain. The mesh will get rotated. How to do parametric sweep, parametric geometry with different parameters. So whenever you want to add any parametric sweep, you can directly have this parametric sweep. And let's say if I'm having three parameters over here, the parameters why they are right here in this case doesn't matter. But just I'm showing you how you can have multi-parameter sweep. You can just add a parameter, provide the range. Next parameter also you can add, and the other next parameter also you can add. So this is how you can add a multi-parameter sweep. This question will also be addressed in a better way when we are having a post-processing session on July 30th. So other options of work plane variation, I'm not sure whether I understood your question or not. Means the other option of work plane variation, exactly it is. There are various means if you mean to say it will not be possible here. Okay, maybe here. If you mean to say that what are the different options available, first of all, you can have different planes, you can have face parallel, similarly you can have edge parallel, edge with some angle, then you can have circle perpendicular also, wherein you can first of all select the circular edge, and accordingly the perpendicular one will be the perpendicular one surface will be selected. As name says, the normal vector, wherein you can directly put the normal vector and accordingly the plane will be selected. You can see that what is the normal vector and the point on that plane. These are the options that you can have. So vertices is nothing but you can define any three points from your existing geometry, and based upon that you can create a work plane. That is this point, let's say this point, and I may have some, sorry, this point, then second vertex I can select like this, and the third vertex maybe I can select like this. And once that is done, you can see that this is the plane which is passing through those 3 points will get created. And this is the coordinates, wherein you can explicitly provide the coordinates for the points which are lying on the plane that you are interested in. And transform is nothing but if you are having the previously created plane. So taking the work plane reference, previous work plane reference, and accordingly create a transformed work plane from that. Means if you want to create have some displacement or the rotation with respect to the previously created work plane. I guess that's what you meant to say, different options in work plane. There is some question regarding that photovoltaic system experiment. I would suggest you please post it to support@comsol.com so that we can suggest you the relevant example models or the relevant case studies what we are having, which will help you to proceed in your modeling requirement. How the rotate feature is different from the revolve feature? Well, the rotate feature will you will be rotating the one geometric entity and creating, let's say, circular array or so. Wherein the revolve feature, you will be revolving a surface around the axis of rotation in order to create. Means normally this revolve feature will be used in order to create a 3D object from the 2D cross sectional area, whereas the rotate operation is typically used in order to create multiple copies at different angles, like creating circular array of the required object. Anushka, there is one question regarding the price of the software. Can you please take that question offline?
Okay, sure, sure, Prajakta.
Yeah. Just a second, I'm still going through. Yeah, there is someone has posted an error that I got following error, that is there are 7099 void equations for variable so and so. Please check that you are having complete physics setup properly. Means, for example, if you are first of all you are having the potential constant given in your model, or temperature constant if you are solving for the Joule heating problem. At the same time, you are having the meshing also done completely for the entire model. Yeah. How to incorporate one sphere into another sphere? Same way that as we were discussing, you can create a sphere and you can just provide the positions of two spheres that you want to draw. That is first sphere that you have drawn. Sorry, the position that you can provide as 0, 0, 0, and the concentric one, if you want to provide another sphere, the same position, maybe you can change the radius, and accordingly you can just have two concentric spheres. In order to see the interior parts, I am again just going to hide some boundaries. So here you can see that two concentric spheres are created. Yeah, three-phase current, as I mentioned that it can be provided in the physics interface itself. While providing the current, you can directly write the phase difference in the physics interface. The pair selection is not clear. So when you're using assembly, the pairs will get created, and those pairs you will have to select under the if it is like identity pair, you will have to select that identity pair under the continuity boundary condition, so that the field variables can be made continuous across that boundary. And here in this case, the identity pairs that you are not creating, COMSOL will automatically create it based upon the way geometry has been created. So while you are having such kind of setup wherein you are having that relative motion between two parts of the domains, the interfacing boundary between these wherein that relative motion is happening, you need to ensure that one set is having union created and the other set of the domains is also having union created separately for that. So we'll be having union A and union B, and between union A and union B, you will be using form assembly so that the object, you will be having identity pair getting created for that automatically. Once that identity pair is created, you can apply infinity boundary condition. Just for an example, here in this case, the infinity boundary condition is available under the definition itself. Is provided. Once you have that identity infinity, you can just click on add, and whatever the identity pair that you are having, you can select and apply. How to add moving mesh? It is available under the mathematical interface, or the same thing is available under the definition. If you go to definitions and if you add moving mesh, here you can add that moving mesh directly. It's applicable with all the physics except solid mechanics, or when you are solving for the structural mechanics problems. Because over there also you are going to work on the material frame. With moving mesh, you are going to work in the material frame itself. How to change from one coordinate system to another coordinate system? Very good question. So first of all, in definitions, you can have this right click on definitions, and here you can select the coordinate system. Let's say I am using the cylindrical coordinate system. Now these coordinate systems can be used while defining the material properties, or let's say while defining the physics interfaces itself. So here in this case, while defining these permanent magnets, right, we wanted to have radially inward and radially outward permanent magnets. So in that case, I can directly change. By default, it could be the global coordinate system, wherein I can provide the inputs in the XYZ coordinates. That also can be provided, or you can, if you want, you can just change the coordinate system like cylindrical, wherein the radial components can be provided. Likewise, you can change any other coordinate system as well. How can I add three physics separately? Whenever you are building the model, if at any point of time, if you want to add any physics, you can right click on the component, whether it is 3D or 2D component, doesn't matter. Go to add physics window, means click on add physics. After that, you can select the required physics, whatever you want to have from any of these portions. Let's say I'm just going to add some heat transfer in solids. Double click on that, or click highlight that and click on add to component. To close the window, you can click on this reset desktop, or you also get a cross button over there. And this is how you can add n number of physics interfaces in your same modeling window. Okay. We are almost towards the end of the session. I will take a couple of questions if I can. The trial license is typically valid for the 2 weeks. Yeah, suppose I have XYZ coordinates of the airfoil data. How can I plot these and connect these points to form a closed curve? While drawing geometry, under geometry, you can see we are having interpolation curve as well. And in that interpolation curves, you can have these what I can say, the data provided directly over here, directly in the tabulated format, one by one you can provide, or you can import any ASCII file, like text file, Excel or CSV data into this interpolation curve. In similar way, if I'm right clicking on geometry, here also I get lots of primitives like interpolation curves. Like in 2D, you can also have that interpolation curve. In 3D, again, it could be open curve, or you can have a closed curve also. That is, starting point and the end point will be connected together in order to create a closed curve. Once you have created a closed curve, you can convert into solid. Okay, so that's it for today. I hope we could answer most of the questions what you had posted today. If there are any questions still left unanswered, please feel free to write at support@comsol.com. If there are those questions are not answered in today's session, We will definitely try get back to you with the required answer and the required information for the same. Thank you. Anushka, do you want to take over the session?
I just hello. I
Yeah.
wanted to know if everybody is able to hear me.
Yes.
Okay, thanks, Prajakta. So basically, I just wanted to tell that this session is recorded. So I'll share the recording of this session with you by after this session, and also we'll share the solutions of assignment number 2, so that what all doubts you have while uploading the assignment, you will know. So yeah, that's all. So tomorrow we have the day 3 session of the training course. So I would request you to please join. So thank you everybody. Thank you, Prajakta.
Yeah. Thank you. Thank you all. Thank you all. Have a nice day. Bye.